The hardest part about maximizing and minimizing quadratic formula questions is often finding the equation if it's not given to you. This is a very classic example of a problem that we need to be able to do not only in a pre-calculus context, but could also come up in a calculus context. So let's read it through. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders a straight highway. If the farmer does not fence along the side along the highway, what is the largest area that can be enclosed? Okay, so we have a highway here, and don't worry, the cows are going to be fine. The highway already has a fence along it to protect the cows. What we want to do is we want to create a fence that is a rectangular shaped, and that is going to help us keep the cows penned in, right? So we have a total of 2,000 meters of fencing to create the three sides of the fence that we need to put up. So here's the first thing. If I label this side X and this is a rectangle, is there another side that is going to have a length of X? Well, yes. Oops. Sorry, y'all. Yes, the opposite side is also going to have a side of X, right? Let's see if we can get this done. There. Now, remember, we have 2,000 total feet. So this side plus this side plus this side has to equal 2,000. So let's, for just the moment, label this side Y. But we know that X plus Y has to equal 2,000 feet, right? So that's 2x plus y has to equal 2,000 feet. Well, if we get y by itself, that side can be represented by 2,000 minus this x, and what's left will become this length over here. So this side will be 2,000 minus 2x. Now, the next thing that you need to do, once you've kind of got a picture drawn and you're thinking, okay, X is the length of this side, Y is the length of this side, which is going to be 2,000 minus 2X. We have to ask ourselves, what are we trying to make the biggest or the smallest? Remember, biggest or smallest when it comes to quadratics happens at the vertex. So we always want to find the vertex. So as we read along here, we can see if the farmer does not fence along the side of the highway, what is the largest area? That right there tells me, oh, I need an equation that involves area of this rectangle because we want our cows to have the biggest possible area to roam in. So how do I find the area of this rectangle? Well, let me just put this in. It's just x times y, right? X times y is the area of this rectangle. But remember, we want to have this into two letters so we can find a vertex. But what is y? Well, that's 2,000 minus 2x. And if we do a little bit of simplification, we get 2,000x minus 2x squared, and a quick rearrange, look at what we've got. Area equals negative 2x squared plus 2,000x, and then our constant would be plus 0. Y'all, this is a quadratic equation. And where is the maximum on a quadratic equation that opens down? Oh, it's at the vertex. So we're going to find our vertex. Whenever we want to maximize or minimize a quadratic that is in the shape of a parabola, we usually want to find the vertex. So remember, how do we find the vertex? Negative b over 2a. So negative 2,000 over 2 times negative 2. That's 2,000 divided by 4, which is 500. To find the area, the a value, we're going to plug that x back into our equation, and that will be the y value of our vertex. So that is negative 2 times 500 squared plus 2,000 times 500, and we're going to pop that into our calculator just really quickly. And we get 500,000. Now, we want to make sure we write our vertex. So the vertex is x is 500, y is 500,000. But remember, this isn't an X and a Y. This is an X and an A. And what is X? X is the length of this side. And what is A? A is that area that we are maximized at. So when the question is, what is the largest area that can be enclosed? What is the answer? Well, 500,000. And since we are in meters and this is an area, square meters is the maximum possible fenced in area we can make using a rectangle. Sometimes they will ask you for the dimensions. If they ask this, they want to know what is X and what is Y. So remember, we know that the X that will maximize us is 500. If we plug that back into this equation right here, we get y equals 2,000 minus 2 times 500, or y is 1,000 meters. So the dimensions that we would want to write would be 500 meters by 1,000 meters. And that is kind of how you would write that.